Guys, hello everyone. I hope that all of you are doing great. A very warm welcome back to my channel. So, as I told you that we are going to be studying about matter, and along with matter, I'm going to also cover another very important topic that is going to be Henry's law. So, we are going to study about different types of matter along with Henry's law. Very important for your examination. So, we are going to study about it completely in this particular lecture. So before starting, what are we doing for the people who are new here? So we are studying about EMRS, KVS, NVS, Tier 2 examination, and it is focused upon TGT science syllabus. Okay, so I've already created one video on cell and another video I've created on matter, on the chapter matter only, where we studied laws of combination. Very important video, and this is a video which actually confuses many people, so I've made it very easy for you to understand. So you guys check out both the videos, and this one is the third video that we are starting today. Okay, so now let us begin with our topic. So as we have discussed in the previous lecture, I'm not going to go over the flowchart again. You can just go through that flowchart in the previous video that I created, where I have shared with you the complete flowchart on matter. Okay, matter is anything that has mass and occupies space, and I have classified matters into different properties, which is there. Okay, so you can check that video out. So now I'm going to move forward with types of matter. So when I talk about the types of matter, so here I'm going to talk about the chemical composition part. We have where we have studied about two different kinds, that is going to be pure substances and mixtures. So first of all, in our syllabus, it is mentioned that you have to describe both of them, that is pure and mixture. So we are going to do the same right now. So when I talk about the pure substance, so it is further classified as elements and compounds. Okay, and the mixtures are further classified as homogeneous and heterogeneous. Again, I'm mentioning I've given the complete flowchart in the previous video. You can check that out. Okay, it is going to be very helpful. Okay, so this is what we are going to study in this particular topic of mixture and pure substances. So so when I talk about element, now firstly let's talk about the pure substances. Okay, so pure, as the name suggests, pure, they have same composition. Okay, all the atoms and molecules inside them is made up of, they are all same. Okay, so we can say that it has same composition. Okay, throughout, and of course, if the composition is same, the whole of the pure substance is going to have a chemical properties which is going to be same as the participating elements. Okay, for example, like there is a pure gold. I'm not talking about the one which is used in jewelry, because it is mixed with other components to make it more stable, and because really the pure gold, if it is used, so it is like having very low melting point, and it tends to melt even like in a hot weather, so we usually don't use it for jewelries. It is a mixed metal, but I'm talking about here the pure one. Okay, so it is going to be pure. Okay, so whole of the compound is going to be made up of coal particles only, Au particles only. Okay, now when I talk about the pure substances, so they are further classified as elements and compounds. So if I talk about elements and compounds, so elements are the ones which are made up of only one type of atom. only one type of participating particles. Okay, so therefore their physical and chemical properties would be same as the participating particles. For example, if I have these molecules and they're combining, so there is a certain property that is shown by these molecules, and when they combine together to form a compound, to form an element, so this element as a whole is going to be showing similar properties as these independent molecules. Okay, so this is what is element. Okay, elements have same composition. When we talk about compounds, so the compounds are made up of two different types of pure atoms and molecules. So two different atoms and molecules, okay, that are pure within themselves. For example, I have two different molecules, say molecule number A and molecule number B. Okay, so they have A and B have their own independent physical and chemical properties, but when they combine together to form a compound that is AB, so this property is going to be different than the property of A and B. It is going to create a different kind of a compound which has its own unique properties. Okay, so this is what a compound is. I hope that I was able to explain you very well. Okay, now let us come to the next part, that is mixture. So when I talk about the mixture part, mixture is, as the name suggests, it is made up of different participating particles. Particles, like if I say particles, it means atoms and molecules. Okay, so the participating particles are different. Okay, of course, if they are going to be different, so the physical and chemical properties are going to be different than the participating elements, and also the whole composition is not going to be same. Composition is going to differ throughout the compound. Okay, throughout the whole compound, the composition is going to differ. Okay, now we have seen here that it is further classified into homogeneous and heterogeneous. So now let us focus on homogeneous and heterogeneous. So when I talk about homogeneous, as the name suggests again, homo means same. Okay, so not same here in the sense, you can, in this particular sense, you can say that it is uniformly distributed. What does this mean? For example, I'll tell you like a normal daily life example. Salt water, saline. So the salt water, if you take some water and put salt into it, you put salt into some water, then what would happen? And if you stir it, okay, then you will find a clear solution, and you are really not going to be able to differentiate if it is salt water or not. Okay, roughly. Okay, we are not able to like see clear distinction between different participating substances. Okay, here we have two participating substances, that is salt and water, but they together they amalgamate in a way that we are not able to differentiate it, and we are not able to separate it. Okay, by physical means, of course. Okay, so this is what is known as homogeneous. When we talk about heterogeneous, so heterogeneous is, hetero means distinct, distinct. So they are having distinct layers. For example, very famous example, oil in water. So when we have oil in water, when we put oil in water, so it tends to float or either sink depending upon the density. It also forms droplets within the water molecule within the water. Okay, so here we can distinctly see with our naked eyes only that like there are two different kinds of participating members, they are not able to homogenize, or they are not able to, dissolve into each other. Okay, they are not dissolvable, and by the physical means, we can of course separate both of them. Okay, by using a normal filter paper, we can separate it. So, hence, this is how we define homogeneous and heterogeneous. Okay, we also have अच्छा we also have to study about very important topic of colloids. ये भी है आपका. This is also mentioned in this syllabus, so we are going to study this as well. This is going to be a separate video, and this is a beautiful video, very good video. Okay, and you'll be able to understand the whole topic very well. So I'm going to do that also. Okay, but in this video we are going to restrict ourselves to this only. Okay, that is types of matter which we have studied, like pure and mixtures needed to be studied, which we have done. Now let us come to Henry's law. Now, very important, Henry's law, and oftentimes it's a confusing subject for many. It's a confusing topic basically for many students. But I'm going to make it very easy for you. Don't worry. So we are going to see Henry's law. So Henry's law, again, it is named after the scientist who is called Henry. Okay, for sure. So the scientist name is Henry, and he basically quantitatively described the relation between solubility of a gas in a solvent on the basis of pressure. So I'll just write the crude definition here, and I'll be able to explain it to you further. But just let me write it, because this is what you have to write in your exam. Okay. So he quantitatively, I'm just writing the keywords. Okay. बीच की कहानी you write on your own. Quantitatively described what? He quantitatively described what? He described the relation between the solubility of gas, where in a solvent. Okay, on what basis? On the basis of pressure. This is the whole story which I've written here. Okay, and I'm going to make it very clear, crystal clear to you in just a second. Okay, so listen very carefully. The relation is, or rather, I should say, the equation C is equal to KH dot X. So I'm going to explain you this whole expression. You have to mark it like this on your answer sheet. So what does this mean? What does this mean? Here C depicts the concentration. Here K signifies Henry's constant, and here X is the solubility. Okay. Um, I'm so sorry, just correct this here. I'm so sorry. This X is the mole fraction. X is the mole fraction. So now I'm going to tell you how do you understand this, okay? It said that whenever we increase the pressure, okay, the solubility of the gas also increases, okay. This is the observation that has been made by Henry, and you have to know this observation as it is. It has been proven experimentally, okay, so which we do not need to study here. We just need to know that whenever the pressure of a gas is increased, the solubility of a gas also increases. For example, you know the LPG, right? Liquefied petroleum gas. Here, the gas is liquefied. How the liquefaction happens, it is via increase of pressure only, right? So whenever the pressure is increased, the gas gets liquefied and hence used for our home purposes, right? So they liquefy, and this gas becomes more soluble in the solvent. So that's why we are able to store it well in cylinders. Okay. Now, this Henry's law, it has like applications also. It has many important applications that you need to write in your exam. Very important. When I talk about the applications, so first application is your cola manufacturing. Now, the CO2 gas is there, which produces fizz, which you observe in a cola bottle. Now, this fizz is going to, how it is made to remain inside that container, that bottle container, okay? So, how is it able to be inside that container? I'm so sorry, I think I just made a weird bottle. I'm sorry. So, I want I want to make a normal bottle. So, if there is a cola bottle, say this is a cola bottle, okay? So here, there is like fizz, okay? Like fizz is inside, and this is the liquid. Okay, this is the cola that we have. Okay, now this fizz is inside this container because it has been sealed under high pressure. It has been sealed under high pressure. High pressure, due to the high pressure, the solubility of the gas increased, and hence the CO2 gets dissolved into this cola. So that's why whenever you open this, you are reducing pressure and the solubility reduces, okay, and it just gets back into this its phase state, okay. So this is the first one. Second one is very important, again, a real life example of scuba divers. Scuba divers, what happens is that when they go deep into the sea, okay, when they go deep into the sea, so inside the sea, the pressure is going to be higher and the solubility of gases is higher. Okay, so what happens is that the nitrogen gas, due to high solubility, the nitrogen gas under high pressure tends to solubilize into the blood of the diver. Okay, which can cause, serious problems. Okay, like this nitrogen can get stuck into the vessels, in what which vessels, in the blood vessels, okay, so it can get stuck into the blood vessels. Like when the diver moves back towards the land, the pressure would again reduce, and the solubility would also reduce, and thereby what would happen is that this nitrogen can, form major, like it cause major blockages in the blood vessels. So what happens is that to counter that, into the tanks of scuba diver, there is some other gas, that is helium, is added to counteract that. Okay, so these are the two major, you can write the two major Henry's law K applications, you can write. But there were certain limitations as well. So let's discuss that also. What were the limitations of his law? His law was good, but there were certain limitations, like it only applies to a stable system. If the system is dynamic, it is not going to be applied in that case. Secondly, it cannot be applied into the high pressure. Like there is a pressure and there is high pressure and there is very high pressure. So in the cases of very high pressure conditions, it cannot be applied. It cannot be applied. Okay. So this was all about Henry's law that you need to know, that you need to write. Okay, this was only needed. Just put it into your own words and you're good to go for an answer. So I hope you liked the video. I hope you understood the concepts well. If there is any doubt left, you can of course comment section is open for you guys. You can comment down below. And also, if you like the video, just go and subscribe to the channel. It gives us motivation to create more beautiful videos for you guys. And also leave a like for me so that I know that you were able to understand the video well. Thank you so much, guys. Have a very nice day. Bye.